we now discuss the solution of a problem that has appeared in the TS set, Telangana State Eligibility Test 2023 Mathematics, and it is from the section Group Theory. These questions are relevant for all the aspirants of junior lecturer, degree lecturer, TS set and AP set aspirants also. This is the question number 69 from the question paper TS set 2023 Mathematics with this ID. The given question is, let G be a simple group of order 60. G be a simple group of order 60 and H be the finite abelian group with phi, the mapping from G to H, be a non-trivial group homomorphism. Phi is a group homomorphism from the group G into the group H. Then the order of H can be, we are given 4 options. Option 1, 30. Option 2, 120. Option 3, 36. Option 4, 90. The order of H can be. Let's now discuss the solution of the problem in detail. We have G is a simple group of order 60 and we are also given H is a finite abelian group. We are given phi is a mapping from G to H, which is phi is a non-trivial group homomorphism. Now we apply the first isomorphism theorem. What is first isomorphism theorem? If phi is a group homomorphism from a group G to a group G prime, then G by ker phi is isomorphic to phi of G. So the first isomorphism theorem states that phi is a group homomorphism from one group G to another group G prime. We are not saying on to. Then G by the kernel of phi is isomorphic to phi of G, that is the image of G under phi. Now you might have studied the first isomorphism theorem in a different way. Like if phi is a group homomorphism from G on to G prime, then the result is G by ker phi is isomorphic to G prime. But if it is just 2, then G to G prime, not on to, then G by ker phi is isomorphic to phi of G. Now phi is given to be a non-trivial group homomorphism from G to H. Therefore, we apply first isomorphism theorem. By applying that theorem, we get G by K is isomorphic to phi of G, where K is the kernel of phi, and phi of G is a subgroup of H. When phi is a homomorphism from G to H, then phi of G, the image of G under phi, is a subgroup of H. Given G is a simple group, what do you mean by G is a simple group? G has no non-trivial normal subgroups. Now let's look at K. What is K? The kernel of phi. The kernel of phi is a normal subgroup of the domain group, that is G. So when it is a normal subgroup of G, K should be the subgroup consisting of E alone, or K is the whole of the group G. Why? Because G is simple. G is simple means it has no non-trivial normal subgroups. That means when G is simple, it has only trivial normal subgroups. So these are the trivial normal subgroups. Only two trivial normal subgroups. Agreed? So now, if K is equal to the whole of G, the kernel is the whole of G. So that means all the elements of G are mapped onto the identity element of H. That means phi is a trivial homomorphism. It's a contradiction. Why it's a contradiction? Because phi is given to be a non-trivial group homomorphism. This contradiction shows K is not equal to G. Therefore, K must be equal to the subgroup consisting of identity element alone. Now, G by K is isomorphic to phi of G, which we have already seen, and taking the modulus, that means this implies order of G by K. K is the subgroup consisting of identity element alone is equal to the order of phi of G. G by K is isomorphic to phi of G will imply the order of G by K is equal to order of phi of G. But K is equal to the singleton set consisting of the E alone. So the order of G by singleton set consisting of E alone will be order of G by order of E. But order of E is 1. Therefore, order of phi of G is equal to order of G only. And order of G is given to be 60. Therefore, order of phi of G is 60. Note that we have already seen that phi of G is a subgroup of H. Phi of G is a subgroup of H. Now apply Lagrange's theorem. Then the order of phi of G divides order of H. The order of phi of G divides order of H by Lagrange's theorem. So this means what? Order of H is a multiple of order of phi of G. Order of phi of G. Order of H is a multiple of order of phi of G. But order of phi of G is given to be we have seen it to be 60. Therefore, order of H is a multiple of 60. Let's see once again. Order of phi of G divides order of H by Lagrange's theorem. Therefore, order of H is a multiple of the order of phi of G. But the order of phi of G is equal to the order of G is equal to 60. Therefore, order of H is a multiple of order of phi of G is equal to 60. Therefore, order of H is a multiple of 60. So, the order we have found, and it is a multiple of 60. And what it is exactly, we have not concluded yet. But let's look at our options. The order of H can be option 1 30, option 2 120, option 3 36, option 4 90. And we have proved order of H is a multiple of 60. In these options, the only option 2 120 is the multiple of 60. The others are not multiples of 60. So therefore, from the given options, order of H can be 120. Can be 120. So the answer to this question is option 2. That is 120. Order of H can be 120. And that is the detailed discussion of the solution of the problem from the group theory that has appeared in the TS Set 2023 examination. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.